I'm Danica.
And I'm Kanan.
So we're going to talk to everyone a bit about the physics behind paper airplanes. To start off, I'm going to ask you a quick question. How long do you think the wingspan of the largest paper airplane ever built was? We'll give you all a minute to come up with an answer. All right. So the answer, drumroll please, is 18 meters.
So the biggest paper airplane ever built, like we just said, was about 18 meters long. Now, if you're like me and have no clue how big that is, it's longer than your school buses. Think about how tall your gym, like your ceiling is, and then double it. And that's just around where you would think the width of the biggest paper airplane is. And that's all, like we said, just one single wingspan of one paper airplane. We have a picture of it here where you can see the moment that it was launched.
All right, on to the actual physics of flight, or aerodynamics. Aero being air, dynamics being movement. We have to introduce you to the 4 basic forces that act on an object in air. In our case, we'll be looking at paper airplanes. The forces acting on a plane can be summed up by a forwards force, known as thrust. The force that opposes thrust is known as drag. And the opposing, of course, the force pulling us all back to ground and keeping us all from just floating away into Earth is gravity. The force keeping the plane from immediately crashing into the ground is called lift. Well, that's great and all, but how do these forces work?
So 2 of them are fairly obvious to anyone that's been in a car or jumped on a trampoline before. We're starting with thrust. Thrust is the force that causes planes to travel forward. We see obvious examples in things like rockets or speedboats. It's a force that propels an object in the direction of its motion. Next is one that I'm sure you're all well aware of since you're experiencing it right now, gravity. Gravity is the force that brings you back down after a sick double jump on a trampoline. It's the force that's keeping you all from just floating off into space. If you want the boring explanation, it's the force that pulls 2 objects that have mass or weight towards each other.
Now we get into the weird air-based forces. Let's start with the force that opposing thrust that causes planes to slow down as they glide through the air, drag. If we look at this cat here, their motion is directly downwards. We can see 2 instances of drag. One, while the cat is free falling, you can see that their fur is flying upwards. But if we look at the second case, they're experiencing far more drag with the parachute since they're falling much slower. More drag just means that there's a stronger force opposing the direction of motion. So drag opposes thrust. What exactly does lift do? Well, much like drag to thrust, lift opposes gravity. So let's take a look at the flying squirrel. The squirrel's motion is forwards, so the drag must be backwards, which leaves the force of lift caused by the pressure of air molecules up on the wings to counteract gravity. That allows the squirrel to safely glide over to the tree.
Okay, so we've talked about the 4 basic forces of flight. Now let's look at the build of the plane itself. To understand how the weight of the plane affects its flight, we have to think about where most of its mass is concentrated. That's called the center of mass. If you've ever tried balancing a pencil on your finger, or say this plane we have right here, you can see that center of mass is where the plane is able to balance itself, like without tipping over to either side. So if we apply that to planes, we can see that the center of mass could be in the center of the plane, where the plane would fly parallel to the ground since the front and back of the plane are perfectly balanced. Or it could be closer to the front, where the plane would then tilt downwards during its flight, causing it to nosedive into the ground. Or it could be near the back of the plane. This would cause the back to tilt down, causing the plane as a whole to be tipped upwards during its flight until gravity takes over lift and it falls straight to the ground. So finding a good balance for the center of mass can actually be really helpful for your planes.
We've thrown all this information at you about how flight works. So let's get started with the fun stuff. Let's play around with some planes and see all these things for ourselves. So the best way to model flight is obviously by making our own paper airplanes. There are 3 main types that we've built to show the science for you guys.
So the first plane we're going to show you is one I'm sure most of you are already familiar with. It's the Dart. It's your classic paper airplane. It's fairly long and it's got a narrow design for a plane, meaning that the lift can be hard to achieve unless it's thrown with significant force. The center of mass for the Dart is roughly around the middle, but it's slightly closer to the nose. So when you throw it, it could either be parallel to the ground or tipped upwards just a little bit, and either way it'll fly just fine.
The next one we're going to show everyone is the Raven. It's a much smaller plane than the Dart, but the wings are still just a bit larger. This means that it needs to be thrown fairly hard, but not quite as hard as you would throw the Dart. The center of mass is much closer to the nose of the plane, so you'll want to tip it upwards when you throw it to balance out lift and gravity.
And the last plane we'll be talking about here today is the lock bottom. The lock bottom has a much larger wingspan and it has a much smaller body, so you'll want to throw it with barely any force at all. The center of mass is roughly near the middle, but slightly closer towards the tail of the plane, so you'll want to throw the plane straight or slightly downwards.
So we've spoken about some of the plane types that you can try out, but what if you want to add a little spice to the plane? Well, you can actually modify the base plane quite easily. Let's show you some examples of structural modifications on some real planes. First off, we have the back flaps that are used to control the altitude of the plane. If the back flaps are tilted upwards, the air will push down on the flaps, forcing the back of the wings to tilt downwards and the wing to tilt upwards overall, and increasing the height of the plane. If the back flaps are tilted downwards, the air will hit the bottom, pushing the back of the wing up and causing the wing to tilt downwards overall and the height of the plane to decrease.
Next, let's take a look at some stabilizers. Stabilizers, shockingly enough, help with the overall stability of the plane. We have vertical stabilizers that keep the nose of the plane nice and straightforward rather than swinging back and forth like the tail of a super excited duck. And we have horizontal stabilizers that help prevent the plane from rolling around like possibly that same dog having the time of their life in the dirt. You can add these and so many other modifications to your own paper airplanes to change how they fly. But to understand how any of the modifications we've just explained to you translate to paper airplanes, we're going to let you watch a video with our friends Caleb, Callum, and Hannah, and they'll be able to show you how those apply to real life.
Hello everyone. So, Danica and Kanan have just shown you the basics of flight. So now, let's put it into action.
As you saw before, we have the Dart, the lock bottom, and the Raven. With these three planes, we can show you all how the shape of the plane changes the flight path. Which one do you think will win? Make a guess now, but don't tell anyone. Let's see if you're right later on. Caleb, would you like to do the honors?
I would love to. Before I throw our first plane here, the Dart, let's discuss the best way to throw it. You'll want to throw this one with more strength, since you won't be able to get enough lift with the thinner wings. The flight path relies more on the thrust, or throwing power, of the Dart, so this plane is great for distance.
Wow, check it out! That plane flew really far! Nice throw, Caleb! As you can see, the Dart already has quite a good flight, flying far and managing to stay pretty darn stable. Its air-like shape helps it stay on a straight path as it flies through the air.
I know, right? Well, we can totally make it go farther. Let's add some back flaps to this mad lad and see how that works. Here, you can see that Caleb aimed the Dart downwards, and wow, the path of flight completely changed. The addition of the back flaps caused the plane to fly upwards.
Yeah, the back flaps totally added to the lift of the plane.
I know, right? On to the next one. Next, we have the Raven. This one needs to be thrown with less strength than the Dart due to the plane's balance, or center of mass, being closer to the front.
So what you're going to want to do here is counteract the gravity with more thrust and lift. And thanks to the Raven's wing shape and small profile, it's also a great plane for distance.
Great throw, Caleb. As you can see, the Raven manages a great deal of lift, but once it reaches the peak, it goes down fast. This is due to the center of mass being closer to the front of the plane. Let's see how adding stabilizers changes the path.
Here you can see that this plane didn't get as much lift as the previous one. This is because the surface area of the wings is smaller with the addition of the stabilizers. Now, the Raven was already a fairly stable plane, so the addition of stabilizers didn't change the stability that much. Alright, on to the last plane.
Now we have the lock bottom. You want a very light throw with this plane as the wide wings will provide a lot of lift for the slow descent, allowing for a longer flight time. However, you might notice that there's a bit of an issue with this one.
Yeah, this one sorta struggles to fly any real distance. Something has to be wrong, and it can't be Caleb's throwing arm. He's been so good this far. But that's okay. We can make our plane better. Stronger, more powerful than ever before.
Alright, calm down, mad scientist. Let's go over how we're going to do that. The last two planes we added back flaps to the Dart and stabilizers to the Raven. But with the lock bottom, we're going to add both and see what it can do.
Now, as you can see here, the lock bottom still has a wonky flight path, but it certainly has more lift thanks to the back flaps, which keeps it flying for longer. The stabilizers don't really stabilize the flight, but they do give the plane more of a direction. Like, well, right towards me. Luckily, it managed to fall short.
Lucky for you. Now that we've seen the 3 planes and their modified versions, there is no doubt in my mind that the modified dart wins for distance and flight time.
Yeah, now let's do a quick recap. So, like Danica and Kay said, flight is a super cool concept that involves 4 main forces: thrust, drag, gravity, and lift. You can test this out yourself by making paper fly, in the form of paper airplanes. We then showed 3 different types of planes, as well as some modifications you can add. Even though we only showed a few of each, there are a bunch of different combinations that you can do. Finally, Caleb finished off with some very cool demos, while Hannah and I explained what was going on.
Thanks, Callum. Now, your teacher should have booklets for all of you that contain instructions to make your own planes. So go, have fun, but be cautious. Don't aim towards people.
I hope you all enjoyed the video and presentation. We hope you learned something cool about planes.
Thanks so much for watching, guys. You guys have been a great audience. Have an awesome day. We'll see ya. Woo!
The planes we've introduced you to so far are all fairly basic. But what if you wanted to try something a little bit more interesting? Well, there are actually some pretty cool designs of planes that everyone can try if you look into it just a little bit more.
We've got on the top left, the red color plane is our catch, right? On the right, we have our F-14 Tomahawk right here. Our orange one is the Canard, and the one on the bottom right is just, a basic jet plane.
Now, they may look a little intimidating, but we can make them, so you guys definitely can.